In 2017, a strange object swept through our solar system. It was slender, tumbling and moving too fast to belong here. Astronomers called it Oumuamua. Some said it was rock, others whispered it was a probe. Then, just 2 years later, another visitor arrived. 2I Borisov. This time an unmistakable comet, but still a warning. Interstellar space was not empty. Now, in 25, a third wanderer has come. 3I Atlas. Bigger, fair, with chemistry that rewrites every rule we thought we knew. What if these arrivals are not coincidence? What if they are part of a sequence? Imagine the stars themselves sending messengers, each one carrying a fragment of intention, each one closer to revealing something we were never meant to see. Tonight, we follow the trail. From Oumuamua's shadow to Atlas's blinding glow. To ask the question no telescope can answer. Are these truly comets? Or are they cosmic signals? A whisper from the stars that we are not alone. Part 1. Messages in the Void. For more than 100 years, our planet has been whispering into space. Not in words, not in deliberate greetings, but in the spillover of technology. Every radio drama broadcast in the 1930s, every wartime transmission bouncing across oceans, every television sitcom carried skyward on invisible waves. Together they have formed an expanding sphere of human noise, a fragile bubble now more than 100 light-years across. Scientists call it the radio bubble, a map of electromagnetic chatter centered on a small blue planet. To anyone listening, it is unmistakable, a faint but structured signal against the natural background of the galaxy. Some of these transmissions were accidents, the unintentional leakage of a civilization still learning to master the spectrum. But some were deliberate, messages in bottles cast into a sea we could barely comprehend. In 1972 and 1973, the Pioneer probes carried golden plaques etched with symbols of our species, a hydrogen atom drawn as a universal yardstick, a map of pulsars pointing back to our sun, and 2 human figures standing beside the outline of the spacecraft, hands raised in what we hoped would be read as greeting. Then came Voyager. In 1977, its golden records left Earth carrying 116 images. Mathematics, DNA, architecture and art, the cry of a newborn child, the songs of whales, and a recording of Johnny B. Goode spinning through the dark. Carl Sagan called it a message to the universe. Others dismissed it as cosmic graffiti. But the most powerful shout came not from a spacecraft, but from a dish carved into the hills of Puerto Rico. In 1974, the Arecibo telescope transmitted 1,679 bits toward the cluster M13. Why that number? Because it was the product of 2 primes, 23 and 73. Any intelligence would know to arrange the stream into a grid. There a pattern would emerge, numbers, DNA, a human figure, and a diagram of our solar system with Earth carefully marked. For 3 minutes, Arecibo outshone every star in the neighbourhood. The message was ceremonial. At 25,000 light-years away, no reply could ever reach us. But the act mattered, because sometimes the sending is more important than the answer. Yet even these focused transmissions are rare. Most of our signals fade quickly into cosmic static. By the time they cross a few light-years, the broadcasts that once filled our skies become whispers, nearly indistinguishable from the hiss of the galaxy itself. Only our most powerful beams survive. Planetary radars designed to map asteroids shine like lighthouses. Their pulses sweep across the stars as Earth turns, a rotating beacon that no careful observer could mistake for natural. The logic behind this search is simple. If we wish to be heard across interstellar distances, we must call out where the galaxy is quiet. That is why astronomers listen at the hydrogen line, 1,420 MHz, the fundamental heartbeat of the universe. And yet, for all these efforts, we have never confirmed a reply. We shout into the dark, but sometimes the silence makes us wonder, what if someone has already heard us? Part 2. The first stranger. In October of 2017, astronomers working at the Pan-STARRS Observatory in Hawaii noticed something unusual. A tiny speck of light was moving just a little too fast across the detectors, its trajectory bending in a way that defied expectations. At first, the team assumed it was just another near-Earth asteroid, one more rock added to the growing catalogue of objects orbiting our Sun. But the data kept shifting. As the orbital calculations grew more precise, a startling truth emerged. The object's eccentricity, the measure of how stretched its orbit appeared, was not slightly above U1 like a long-period comet, but definitively hyperbolic. That meant it was not bound to our star at all. It had entered our solar system from interstellar space, passing through on a one-way journey. The realization spread quickly through the community. For the first time in human history, we were watching an object born around another star sweep through our cosmic neighborhood. It was given a name in the Hawaiian language, Oumuamua, a word meaning scout or messenger from afar. The name felt prophetic. This was a visitor carrying secrets from beyond, a story written in ice and rock across unimaginable distances. Telescopes around the world turned their gaze toward the newcomer. The object was small, perhaps only a few hundred meters long, and fading fast as it receded from the sun. Observations revealed it to be elongated, 10 times longer than it was wide, a shape no asteroid in our system had ever displayed. Its brightness fluctuated dramatically as it spun end over end. One moment brighter, the next dimmer, as if we were watching a tumbling shard of something broken. The more scientists measured, the stranger it became. Oumuamua showed no coma, no halo of waves or dust that comets typically display when warmed by sunlight. And yet, as it passed through perihelion, its closest approach to the sun, it began to accelerate, ever so slightly, but enough to be unmistakable. It was being pushed by some unseen force. One explanation was outgassing, jets of sublimating ice invisible to our instruments, acting like tiny thrusters nudging the object along. But no dust was detected. No vapor trails appeared. If Oumuamua was a comet, it was unlike any comet we had ever studied. This opened the door to speculation. Could it be an artificial object? A fragment of alien engineering? A probe disguised as natural debris? A light sail catching the faint pressure of sunlight? The idea was provocative and fiercely debated. Some scientists urged caution. Extraordinary claims require extraordinary evidence. Others argued that the strangeness of the data demanded open-mindedness. If we dismissed every anomaly, we might miss the most important discovery in human history. Press conferences followed. Newspaper headlines called it the alien asteroid. Public fascination soared, even as astronomers quietly admitted that they might never know the truth. Because Oumuamua was already leaving, by the time most telescopes were trained on it, the messenger was speeding away, growing fainter with every passing night. Within weeks, it slipped beyond the reach of our instruments, a mystery vanishing into the dark. But for those few weeks in 2017, humanity glimpsed something profound. The void was not empty. Other systems did throw their fragments into interstellar space. And sometimes, those fragments found their way to us. The story of Oumuamua did not end with its disappearance. In fact, it had only just begun. For in its wake, we were left with a haunting question. Was Oumuamua simply an interstellar rock, cast adrift by chance? Or had it been a deliberate messenger, the first reply to a century of human transmission spilling across the stars? Oumuamua's mystery grew sharper the longer astronomers stared at the data. The absence of a coma remained puzzling. Typical comets, when warmed by the sun, shed streams of gas and dust. Those plumes scatter sunlight, forming bright tails that stretch for millions of kilometers. But Oumuamua offered nothing. Its surface seemed inert, yet something unseen was still accelerating it. One hypothesis imagined a coating of exotic ices, hydrogen or nitrogen. materials that would sublimate quickly and invisibly in sunlight. But such ices are fragile, unlikely to survive a billion-year journey through interstellar space. Others proposed that Oumuamua was a fragment, shaved from the crust of a shattered planetesimal, its flat shape the result of violent cosmic collisions. Then came the radical suggestion. Harvard astronomer Avi Loeb argued that Oumuamua could be artificial. Perhaps a probe, or a fragment of alien technology, a thin sheet driven not by gas but by radiation pressure from starlight. A solar sail adrift among the stars. The claim ignited fierce debate. Mainstream researchers bristled at the leap toward extraterrestrials. But Loeb reminded them that science requires confronting anomalies, not dismissing them. If an explanation fits no known category, perhaps it belongs to one we have yet to imagine. Beyond the academy, the public was enthralled. Newspapers speculated about alien scouts. Talk shows joked about interstellar tourists stopping by. Science fiction writers seized the moment, crafting tales of silent emissaries drifting between civilizations. Even those skeptical of alien origins admitted the drama was irresistible. Culturally, Oumuamua arrived at a time of heightened awareness about our place in the cosmos. Humanity had spent decades sending out its own emissaries: Pioneer, Voyager, Arecibo's radio pulse. Now something had arrived in return as such. Even if it was only a rock, the symbolism was hard to ignore. Telescopes strained to gather more data. The European Southern Observatory captured spectra. The Hubble Space Telescope tracked its fading light until January 2018. But the object was small and faint, and slipping away too quickly. By the time most instruments could be directed, Oumuamua had already receded beyond reach. What we are left with is not certainty, but questions. Was Oumuamua a comet stripped bare by its journey? A shard of frozen nitrogen torn from a Pluto-like world? Or was it something that defied those categories entirely? The truth may never be known. The messenger is gone, its secrets carried back into the interstellar dark. But what it left behind is perhaps more important than answers. It left us with awareness that the stars do not only receive, sometimes they send. Oumuamua taught us that we are not isolated. The void is not empty silence, but a crossroads where fragments of countless systems drift, each one a message, though we may not yet know how to read it. And perhaps most haunting of all, if this was the first scout, then what comes after? Part 3. The Second Visitor. In late August of 2019, while the world's largest observatories scanned the heavens, the breakthrough came not from a billion-dollar facility, but from the patient work of a single amateur. Gennady Borisov, an engineer and hobbyist astronomer in Crimea, had built his own wide-field telescope by hand. On August 30th, he noticed a faint, fast-moving object in the dawn sky. At first, it seemed like an ordinary comet, but orbital calculations soon revealed the extraordinary. This visitor was not from here. Its eccentricity exceeded 1, placing it on a hyperbolic trajectory. It was the second confirmed interstellar object, and it bore his name 2I/Borisov. Unlike Oumuamua, Borisov looked familiar. It sported a komedash, a glowing envelope of gas vented from its icy surface. It grew a tail, a luminous ribbon streaming into the void. Where Oumuamua had been a puzzle, Borisov seemed like reassurance. The world's great observatories turned their attention toward the comet. Hubble, ALMA, the European Southern Observatory's VLT. For once, an interstellar traveller had arrived early enough to be tracked in detail. Spectrographs revealed that Borisov contained abundant carbon monoxide, more than is typical for comets born in our solar system. Its chemistry was strange, but not inexplicable. It suggested that Borisov had formed in a colder region than our Kuiper belt, farther from its parent star, in a realm where carbon ices could survive intact. Its nucleus was pristine, untouched by repeated passages near a sun. That alone made Borisov a treasure. It carried within it the raw ingredients of another star system, preserved for billions of years and delivered by chance into our backyard. The discovery thrilled planetary scientists. Here was a chance to compare directly. The comets of our solar system, dusty, volatile, familiar, set beside one born under alien suns. Every molecule it carried was a data point, a chemical clue about the diversity of planetary nurseries across the galaxy. For astronomers still haunted by Oumuamua's unexplained acceleration, Borisov offered relief. It was behaving exactly as a comet should, dust and gas pouring from its nucleus, jets firing as ices vaporized in the warmth of our sun. The laws of physics still held. Not every visitor from the void had to remain a riddle. But Borisov was also a warning. Its hyperbolic velocity was staggering, over 30 kilometers per second. No technology on Earth could hope to catch it. We could observe, but never chase. But it arrived. It revealed a little, and then it left, vanishing forever into interstellar night. As with Oumuamua, the story ended with absence. But together, the two objects had shifted the foundation of astronomy. Interstellar wanderers were not theoretical anymore. They were here. And perhaps they had always been here, passing unnoticed through the solar system while we were too blind to see. Telescopes worldwide raced to collect every possible photon from Borisov. The Hubble Space Telescope tracked its coma, measuring how sunlight scattered through alien dust. Its images showed a nucleus less than a kilometre across. Tiny by comet standards, but luminous with activity. Meanwhile, radio dishes tuned their receivers to catch its spectral fingerprints. ALMA in Chile, perched high in the Atacama Desert, detected gases venting from its frozen core. Carbon monoxide in extraordinary abundance, a signature hinting at a birthplace far colder than our Kuiper belt. For scientists, it was like holding a vial of chemistry from another sun. Comparisons came quickly. Comets of our solar system often bear scars from repeated journeys, fractured crusts, depleted volatiles, faint tails. But Borisov was pristine, as though it had been flung outwards soon after its birth, and had wandered untouched through the galaxy for billions of years. Studying it felt like time travel, a look not only into another planetary system, but into the earliest conditions of our own. Here was evidence that planet formation, the process that built Earth itself, was happening everywhere, not just around our star. Yet even as the data flowed in, scientists knew the window would be brief. By December of 2019, Borisov had passed perihelion, swinging close to the sun and brightening for a final time. In early 2020, the comet began to fragment, breaking apart under the stresses of heat and rotation. Pieces drifted away, until the glow diminished and the traveller vanished into the night. For the scientific community, Borisov was both gift and frustration. A gift because it provided unambiguous proof that Oumuamua was not unique. The galaxy is filled with wanderers. But a frustration because, once again, the object could not be intercepted, only observed at a distance. No spacecraft was ready. No mission could pivot fast enough to chase a body moving at tens of kilometers per second. We were spectators, watching another messenger slip through our grasp. The debates that followed were quieter than those over Oumuamua, but no less significant. Was Borisov typical of interstellar comets? Or was it an outlier? A rare survivor from a distant disk of ice? How many more wanderers might pass our way each decade? And what might we learn if we were prepared to meet them? Beyond the science, there was symbolism. If Oumuamua had been a riddle, Borisov was a reminder. A reminder that the galaxy is alive with motion, that planetary systems scatter debris into the void, and that some of that debris will inevitably cross our skies. It raised deeper questions too. When we look outward, do we see only physics and chemistry? Or do we see messages, not deliberate, but messages nonetheless, written in ice and dust? Borisov seemed to whisper. You are not alone in building worlds. And with 2 visitors arriving in just 3 years, one could not help but wonder. Had something changed? Had we entered a window of cosmic alignment, A corridor where fragments from other suns are more likely to pass? Or was it only now, with better surveys and sharper eyes, that we were finally able to notice what had always been there? By the time Borisov faded beyond detection, the answer mattered less than the implication. Interstellar visitors are not myths. They are realities. And if 2 had already come, then surely more were on their way. Oumuamua had left us with wonder. Borisov left us with inevitability. The universe was sending pieces of itself across the gulf, and we were only at the beginning of learning how to listen. Part 4. The third messenger. By 2025, the idea of interstellar visitors was no longer unthinkable. Oumuamua had startled us in 2017. Borisov had confirmed the reality in 2019. 2 messengers in 2 years. Enough to prove that the galaxy is not silent, that fragments of alien systems drift across the stars. But no one expected a third so soon. On July 1st, 2025, the Atlas Survey telescope in Chile picked up a faint dot of light, moving against the background stars with uncanny speed. Its trajectory was calculated, hyperbolic, unbound to our sun. Another interstellar visitor had arrived. It was named 3I/ATLAS. Third interstellar object ever detected, and quickly it proved to be the strangest of all. At first glance, it resembled a comet, a core surrounded by a coma, jets of vapour streaming away under the sun's heat. But the details unsettled even the most cautious astronomers. Spectral data from the James Webb Space Telescope revealed extraordinary levels of carbon dioxide, far higher than typical comets in our own system. Its chemistry was alien, not in the sense of fiction, but in the sense of belonging to an environment we had never studied. Perhaps a nursery colder, darker, and more volatile than the places where our comets were born. Its size was daunting. Models suggested its diffuse atmosphere stretched for hundreds of thousands of kilometres. One astronomer described it as a sphere of gas half the width of our Sun, surrounding a nucleus just a few kilometres across. The scale was grotesque, a reminder that space does not care for our sense of proportion. As 3I/ATLAS approached perihelion, instruments around the world locked onto it. Ground-based telescopes charted its orbit with precision. Radio observatories searched for artificial signals, finding only natural silence. But speculation was impossible to silence. What if the trajectory was not natural? What if the hyperbolic path was not escape, but a maneuver? A subtle deceleration, hidden beneath the mathematics of celestial mechanics. What if the comet was a disguise? Imagine a probe advanced enough to mimic the motions of natural bodies. An emissary wrapped in gas and dust, its technology hidden beneath a cloak of chemistry. What would we see? Only the coma, only the spectral lines, only what we already expect to see. And in that expectation, we might miss the truth entirely. NASA and ESA were quick to reassure. The object posed no threat to Earth. Its closest approach would remain hundreds of millions of kilometres away. But beyond the language of safety, the unease remained. Because 3 interstellar visitors in less than a decade is more than coincidence. For billions of years, our skies were silent. And now, suddenly, they are not. Coincidence or conversation? The discovery of 3I/ATLAS sparked a global response. Professional observatories coordinated nightly campaigns. Citizen astronomers submitted thousands of images. For months, the object became a shared project, a cosmic guest followed by eyes across the world. The Hubble Space Telescope recorded its evolving coma, swelling and shifting in colour as it neared the Sun. James Webb captured spectra that baffled chemists, ratios of volatiles that did not fit any known model of formation. Meanwhile, radar stations scanned in vain for solid echoes, finding only the diffuse haze of dust. Comparisons with earlier visitors were inevitable. Oumuamua had been sombre, its acceleration unexplained. Borisov had been noisy, its chemistry alien yet comprehensible. Atlas seemed to combine the unease of both. A comet that looked normal at first glance, but grew stranger the closer we studied it. Some scientists warned against overinterpretation. Extraordinary bodies demand extraordinary patience. Natural explanations may yet emerge, if we wait for better data. Others, however, dared to voice the darker possibilities. What if Atlas was not just passing through? What if its strange acceleration, masked within the blur of dust, was a controlled maneuver? What if its hyperbolic course was a performance, meant to appear natural to telescopes trained on celestial mechanics? And what if the vast coma was not a symptom, but a shield, a cloak to hide something more deliberate inside? These questions could not be answered, but they could not be understood either. Every mystery invites stories, and the story of Atlas became a canvas for our hopes and fears. To some, it was a messenger dash, not of danger but of connection, proof that planetary systems scatter fragments constantly, that we are participants in a galactic exchange of matter, each comet a piece of another world, delivered to us as a reminder that we are not alone in building planets. To others, it was unsettling. 3 interstellar objects in less than a decade, after billions of years of apparent silence. Coincidence was possible, but coincidence can also be a comforting word for patterns we do not yet understand. And beneath the science lingered the oldest question of all. When the universe sends visitors, are they accidents? Or are they answers? 3I/ATLAS crossed perihelion on October the 29th, 2025. It shone brilliantly for a brief season, a ghostly sphere against the night. Then, as all comets do, it began its long departure. By mid-December, it had receded to a safe distance, fading slowly into the dark. But unlike Borisov, which reassured us, Atlas left behind unease. Because once you begin to wonder if comets can be cloaks, you cannot look at the night sky the same way again. 3 messengers, 3 stories written in ice and dust, and perhaps 3 signals dash from something beyond. Part 5. The worst case. Every time humanity encounters the unknown, our first instinct is reassurance. We want the universe to be familiar, to behave according to the rules we understand. But what if it doesn't? With 3I/ATLAS dot, the official narrative was comfort. A natural comet, a harmless trajectory. Safe. Predictable. Yet beneath those words lingered unease. Because when astronomers spoke privately, they admitted the signatures were troubling. The carbon dioxide excess, the diffuse atmosphere vast beyond precedent, the faint but measurable anomalies in its acceleration. Individually explainable, collectively unsettling. The worst case is simple and terrifying. What if 3I/TLAS is not leaving? What if the hyperbolic curve we plotted is a disguise? A deceleration maneuver executed by technology beyond our detection. Imagine a civilization millions of years ahead of us. For them, hiding motion within natural mechanics might be trivial. Deploying probes disguised as comets, asteroids, or even space debris could be child's play. How would we know the difference? What we call a coma dash, a cloud of dust and vapor dash, might instead be a deliberate cloak. A veil to scatter our telescopes, to obscure structures hidden within. An atmosphere not of nature, but of intention. In this scenario, 3I/ATLAS is not a rock. It is a platform. A carrier. A long-range probe drifting silently between stars, masked in the language of comets. And what would its mission be? Exploration? Surveillance? Contact? Or something more ambiguous dash? To watch, to wait, to measure us before deciding what to do next. The unsettling part is not the possibility of aliens, but the possibility of patience. Because if Atlas is a probe, then someone has already chosen this moment to arrive. And if they can cloak technology in a comet, then they can choose when to reveal themselves. In that worst case, the question is not whether they exist. The question is whether we will recognize them when they decide to stop pretending. Speculation of this kind divides the scientific community. SETI researchers trained to listen for faint signals urge caution. We cannot declare intent where only physics has been measured. But others point out that physics alone cannot explain every anomaly. The silence of the sky has always been double-edged. It comforts us. No hostile fleets, no obvious threats. But it also unsettles us. Why no voices, no replies? Perhaps, some argue, because the watchers do not need to speak. In the worst-case scenario, 3I/ATLAS is not alone. It is part of a network, a constellation of disguised probes seeded through the galaxy, each drifting for eons, slumbering until it encounters a civilization bright enough to notice. If that is true, then our discovery of Oumuamua, Borisov, and now a TLAS may not be accidents. They may be stages of a process. First curiosity, then confirmation, then a test to see how we respond. What unnerves SETI veterans is not the drama of alien craft, but the subtlety. An advanced intelligence would not need to dazzle us with spectacle. It would only need to blend into the background of the cosmos, to appear as ordinary as a comet, and in that ordinariness, it could pass subtly into our awareness. Philosophers of science call this the problem of recognition. We are prepared to see aliens as strangers. We are not prepared to see them as familiar objects we have misclassified for centuries. Some whisper about cosmic quarantine. Perhaps we are being observed but deliberately left untouched. Like animals in a reserve, monitored but not engaged. If Atlas is such a sentinel, its true function may be to record, not to communicate. And so the worst case is not invasion. It is irrelevance. That we are studied without consequence, measured and catalogued like insects pinned in a drawer. Of course, the simpler explanations remain possible. Unusual chemistry, coincidental alignments, statistical flukes. Science thrives on restraint, on testing hypotheses with evidence. But in the quiet hours, scientists too are human, and they cannot help but ask the question that keeps echoing. What if the worst case is not that we are alone? What if the worst case is that we are not? Part 6. The Search for Patterns. 3 interstellar visitors in less than a decade, after billions of years of Shen. Coincidence? Or conversation? Astronomers began to ask a forbidden question. Were these arrivals random, or were they part of a sequence? A rhythm hidden within the chaos of the cosmos. They charted the trajectories on giant sky maps. Oumuamua sweeping down from Lyra, Borisov entering from Cassiopeia, Atlas racing inward from Lynx. 3 different constellations, 3 paths unconnected by obvious geometry. Yet some noticed alignments. Overlay the orbits. And the arrival windows form a cadence. 2017, 2019, 2025. Not evenly spaced, but suggestive. A beat, a sequence, like a code tapped out across years instead of seconds. Skeptics caution that human minds are wired for pattern seeking. We see shapes in clouds, faces in shadows, design in randomness. Perhaps 3 wanderers in 10 years is only chance, an artifact of better telescopes and more vigilant surveys. Yet the unease remains. SETI researchers began to frame the problem statistically. If planetary systems scatter trillions of fragments into interstellar space, then the galaxy must be crowded with debris. But what is the expected rate of passage through our solar system? 1 per century? 1 per decade? The models are uncertain, but 3 in less than 10 years strained the assumptions. Some went further. What if the cadence was intentional? What if Oumuamua was the scout, Borisov the control, and Atlas the escalation? 3 notes in a cosmic message, theorists played with numbers, intervals between arrivals, angles between trajectories, searching for primes, ratios, mathematical signatures recognizable across civilizations. So far, nothing conclusive has been found. But even the attempt reveals something about us. We cannot resist the urge to look for intention, to imagine that the universe might be speaking in a language we have not yet learned. It may be illusion, but illusions too can teach, because the very act of searching for patterns changes how we see the sky. Every streak of light, every visitor, becomes part of a possible message. And once you suspect a message, silence becomes impossible. Beyond the equations, the idea of patterns spilled quickly into culture. Newspapers speculated about a hidden timetable of visitors. Talk shows asked whether we were in the middle of a slow-motion first contact. Online forums filled with diagrams of orbital paths, lines drawn across constellations to reveal supposed messages. Scientists grew uneasy. Pattern seeking is a double-edged sword. The same instinct that allows us to decode the periodic table, or to map genetic sequences, also tempts us to find meaning where none exists. False patterns can mislead entire generations. History offers warnings. Percival Lowell once saw canals on Mars, straight lines he believed were built by intelligent beings. It was an illusion of the eye, but it has shaped decades of public imagination. In the same way, 3 interstellar visitors might seduce us into seeing a plan, when the truth is only probability. And yet, the very possibility lingers. Because even if these objects are natural, their timing still forces us to confront the scale of cosmic traffic. Perhaps the galaxy is not a quiet desert, but a crowded sea, its currents carrying debris endlessly between stars. If so, then every few years a new fragment may pass through our skies. The Rio scale, normally applied to potential alien signals, was quietly invoked by some researchers. How do you rank the significance of objects that might not just be rocks, but messages in disguise? The debates revealed more about our anxieties than about the cosmos. Philosophers of science suggested a different interpretation, even if the cadence is coincidence. Our search for meaning reflects something profound. We are not content to live in silence. We crave dialogue with the universe, even if the conversation is one we invent. So the search for patterns is not only about comets and trajectories, it is about us. Our need to believe that the stars are not indifferent, that the wanderers crossing our skies may carry intention, even if we cannot prove it. And perhaps this is the real pattern dash, not in the paths of Oumuamua, Borisov or Atlas, but in the rhythm of our own longing. A longing that transforms every fragment of rock into a possible messenger, every silence into a possible reply. In the end, whether the cadence is coincidence or conversation, the effect is the same. We are listening harder now. And once you begin to listen, the universe will never sound the same again. Part 7. The human response. For centuries, humanity has looked to the stars with curiosity. But in the age of Oumuamua, Borisov and Atlas, curiosity is no longer enough. We are forced to respond. The scientific community reacted first. Institutions that had long operated in the margins, SETI, the search for extraterrestrial intelligence, suddenly found their work thrust into the mainstream. For decades, SETI had listened quietly, its radio telescopes scanning the sky for whispers of artificial signals. Now, with 3 interstellar visitors in less than 10 years, the listening took on a new urgency. Breakthrough. Listen. A billion-dollar initiative backed by private funding expanded its search parameters, not only listening for distant stars, but targeting regions of the sky linked to the paths of Oumuamua and Atlas. The logic was simple. If these objects were emissaries, perhaps they came from a specific source. A system broadcasting, or a cluster aligned with their trajectories. Meanwhile, space agencies faced a different challenge. How do you prepare for the next messenger? Catching an interstellar object requires speed, flexibility, and readiness. But existing missions take years to plan and decades to execute. In the wake of Oumuamua, NASA and ESA began sketching designs for rapid response probes. Concepts like the Comet Interceptor, a spacecraft kept on standby at a gravitational way station, ready to launch toward the next unknown visitor at a moment's notice. Other proposals went further, imagining fleets of small probes that could be launched in swarms, blanketing an interstellar object with instruments before it escaped. These were not idle dreams. The lesson of Borisov was clear. If we're not ready in advance, we will never catch them. But the human response was not only technological. It was cultural. Oumuamua and Atlas inspired books, films, and endless speculation online. Some stories lean toward wonder, a galaxy alive with messengers, bearing tales of creation. Others lean toward dread, visitors as scouts, the prelude to contact we're not prepared for. In classrooms, students were asked what they would say to an alien intelligence. In parliaments, officials debated whether humanity even has the right to speak for Earth. Should a handful of scientists transmit messages to the stars, risking replies we cannot predict? Or should silence be our policy, listening without announcing ourselves? The public response oscillated between fascination and fear. Social media spread rumours of signals hidden in Atlas's spectrum, cover-ups by space agencies, and doomsday predictions. At the same time, millions tuned into live streams of telescopes tracking the comet. In a fractured world, a single point of light drew collective attention, uniting people in awe, if only briefly. Military strategists also paid attention, not because they believed Thri Atlas was a threat, but because the unknown must always be considered in terms of risk. White papers circulated quietly, speculating about the implications of unidentified interstellar objects. Could they conceal surveillance technologies? Could they deliver payloads across interstellar distances? Most dismissed the ideas as improbable. But the fact that the questions were asked revealed how seriously the matter was taken. For the broader public, the human response was more emotional than strategic. Some saw in Oumuamua and Atlas a reminder of our smallness, that Earth is a fragile outpost on the edge of something vast. Others saw hope. If fragments can cross the stars, then so can we. Art mirrored these feelings. Painters depicted luminous shards slicing across the heavens. Poets spoke of messengers knocking gently on the cosmic door. Filmmakers imagined first contact not as thunderous arrivals, but as the quiet discovery of objects drifting in silence. Religion, too, found ways to absorb the events. Some traditions spoke of omens, cosmic signs written into the heavens. Others embraced the idea that interstellar visitors were part of creation's design, reminders that the divine encompasses more than one world. But perhaps the most profound response came in philosophy. Thinkers asked what it means to encounter the truly other. Not aliens landing on the White House lawn, but a rock, silent, indifferent, sliding through the solar system without notice. How do we ascribe meaning to that? Some argued that meaning lies not in the object, but in us. That our stories about Oumuamua and Atlas are mirrors, reflecting what we fear and what we hope. Others countered that we must resist projecting ourselves onto the cosmos, that true humility requires accepting strangeness on its own terms. Either way, the human response is undeniable. For the first time in history, our species knows that interstellar messengers are real. And once knowledge arrives, it cannot be unlearned. So we prepare, with better telescopes, with faster probes, with deeper imagination. Because the next visitor is not a question of if, but of when. And when it comes, humanity will once again be tested, not only in our science, but in our imagination, our philosophy, and our courage to answer the knock at the door of the stars. Part 8. The Lessons of Silence. When we look at Oumuamua, Borisov and Atlas, we see motion, data, acceleration, chemistry. But perhaps the most important thing they teach us is silence. Because for all their strangeness, these messengers said nothing. No signals, no transmissions, only the quiet physics of rock and ice, sliding through the void. This silence unsettles us. For a century we have been shouting into the dark. Radio waves, television signals, radar pings, and yet the visitors we receive offer no reply. Philosophers call this the Fermi paradox. If the galaxy is teeming with life, then where is everyone? Why have no ships appeared? No messages been heard? No monuments discovered? The silence of the stars remains profound. The interstellar visitors sharpen this paradox. If objects can travel freely between systems, then surely technology could as well. If fragments of alien nurseries reach us by accident, then deliberate messengers should be possible. And yet, all we have are rocks. One lesson may be humility, that we are still infants in cosmic time, our century of radio chatter a whisper compared to billions of years. Perhaps civilizations rarely overlap. Perhaps they bloom and die like flowers, their seasons scattered across galactic history, rarely coinciding. Another lesson may be caution. Perhaps civilizations choose silence. They learn, as we are beginning to learn, that broadcasting your existence may not be safe, that in a crowded forest, the loudest animal is often the first to be hunted. Still, another lesson may be patience. Signals take time. Our first intentional message to the stars, beamed toward M13 in 1974, will not arrive for 25,000 years. Why should we expect a reply so soon? But silence also reshapes how we see ourselves. Because in the absence of voices from elsewhere, our own voice becomes louder. We hear our transmissions echoing into the void, and realize that for now, we may be the only storytellers awake in this part of the galaxy. That recognition is both sobering and inspiring. If the universe is silent, then every comet and every visitor becomes a text to be read, not in words, but in trajectories, in chemistry, in silence itself. Some scientists interpret silence not as absence, but as a form of communication. A refusal to speak can itself be a message. It may say, "We are here, but we choose not to engage." Others suggest silence is the default state of the cosmos. Stars burn, planets orbit, comets drift. Noise is rare. Signals are exceptions. If so, then our own transmissions are the anomaly, not the rule. Philosophers take this further. They argue that silence is a kind of mirror. When the universe does not answer, we are forced to listen to ourselves. Our questions echo back. What do we hope for? What do we fear? Silence turns every question outward into a question inward. The interstellar messengers embody this paradox. They are voices made of stone, yet they speak only through their silence. We project meaning onto them, alien probes, cosmic debris, divine omens. But the silence of their passage remains untouched, like an unanswered riddle. For SETI researchers, this silence is a discipline. They have learned that extraordinary claims require extraordinary patience, that every candidate signal must be repeated, confirmed, verified beyond doubt. The silence of Oumuamua, Borisov and Atlas reinforces this ethic. Do not rush to declare. Do not confuse mystery with message. But silence also invites imagination. In the quiet left behind, artists paint, poets dream, and philosophers speculate. The silence becomes a canvas, and into that canvas we project ourselves. So what are the lessons of silence? That we are impatient, that we are hopeful, that we are terrified of being alone, yet equally terrified of being answered. Perhaps silence is the universe's way of preparing us, of teaching us to listen more carefully, to filter noise from meaning, to recognize a signal when it finally arrives. Or perhaps silence is itself the signal. A reminder that the cosmos owes us nothing, that wonder and fear and meaning are things we must create for ourselves, and so the interstellar messengers pass by quietly, teaching us their hardest lesson, that sometimes silence is the only answer we are ready to hear. Part 9. The Fragility of Certainty. Every time humanity thought it had found proof of intelligence beyond Earth, certainty slipped away. In 1967, a young graduate student named Jocelyn Bell Burnell noticed something strange. Her radio telescope picked up a signal, precise, regular, repeating every 1.3 seconds. It was so exact, so clockwork, that she and her colleagues half-jokingly labelled it LGM-1. Little Green Men 1. For a brief moment, the world hovered on the edge of revelation, but soon the truth emerged. The signal was not artificial. It was a pulsar, a neutron star spinning with unimaginable precision, sweeping beams of radio waves across the galaxy like a lighthouse. Nature, not intelligence, had written the code. A decade later came the WOW signal. August 15th, 1977. Ohio State University's Big Ear radio telescope recorded a narrowband burst that lasted 72 seconds. It was exactly what SETI researchers had predicted an alien signal would look like: narrow, intense, and aligned with the hydrogen line. Astronomer Jerry Eamon circled the data printout and scribbled one word in the margin: wow! To this day, no one knows what it was. A one-time transmission from a distant world? A reflection of Earth's own radio chatter? Or a natural phenomenon still unknown to physics? The WOW signal remains both tantalizing and unresolved, a monument to the fragility of certainty. More recently, in 2020, Parkes Observatory in Australia picked up a narrowband signal from the direction of Proxima Centauri. It was labelled BLC-1. For weeks, whispers spread that perhaps we had finally found a neighbour. But careful analysis revealed the culprit: radio interference from human technology, masquerading as something cosmic. Each of these moments follows the same rhythm: discovery, excitement, doubt, resolution. And always the resolution points back to nature or to ourselves. But Oumuamua, Borisov and Atlas trouble this rhythm, because here, the resolution has not come. We do not know what Oumuamua was. We do not know why Atlas behaved so strangely. We are left not with closure, but with mystery. And that makes the fragility of certainty more dangerous than ever. Because in the vacuum left by silence, speculation grows. And speculation, once unleashed, is hard to control. Certainty is fragile because knowledge is provisional. Every conclusion we draw rests on data, and every dataset is finite. The cosmos is vast. Our instruments are small. Between those two truths lies an ocean of uncertainty. Astronomy has always lived with this tension. We infer planets from the wobble of a star. We deduce black holes from light that does not escape. We build narratives on hints, always aware that a better telescope may overturn them. And so, when interstellar visitors arrive, we are quick to speculate. But speculation is not certainty. To leap from anomaly to alien is tempting, but history urges caution. The canals of Mars, the pulsars mistaken for messages, the WOW signal burned into our imagination. Each case shows how easy it is to misread the universe, to mistake wonder for evidence. Yet there is danger in the opposite mistake as well: to dismiss anomalies too quickly, to explain away mysteries because they are inconvenient. Science demands humility on both sides. Do not claim more than the data allows, but do not blind yourself to what the data might suggest. The fragility of certainty is also the beauty of science, because every time our confidence breaks, we are forced to look closer, to refine our tools, to question our assumptions. Certainty may fracture, but understanding deepens. Oumuamua, Borisov, Atlas. Each one reminds us that the cosmos is stranger than we expect. Each one teaches us that humility is the price of discovery. Perhaps the lesson is not to fear uncertainty, but to embrace it. Because in the spaces where certainty fails, wonder begins. And if the universe is trying to teach us anything, it may be this: that the fragility of certainty is not a weakness, but the very doorway through which discovery enters. Part 10. The Cosmic Mirror. When interstellar visitors sweep through our skies, they do more than carry data. They hold up a mirror to us. Oumuamua revealed our hunger for mystery. Faced with an object we could not explain, we filled the silence with speculation. Was it a rock? A probe? A messenger? The debate told us as much about ourselves as about the object. Borisov revealed our reverence for evidence. Here was a comet that behaved by the book, and yet was utterly alien in its chemistry. We celebrated not speculation, but measurement, spectra, velocities, ratios of gas. In Borisov, we saw the part of ourselves that trusts the data, even when the story is quiet. Atlas revealed our fear of intention, its vast coma, its odd chemistry, its unsettling trajectory. All of it provoked a darker imagination. What if this was not just nature? What if someone was watching? In Atlas, we glimpsed the part of ourselves that fears being observed without knowing by whom. The cosmic mirror does not flatter us. It shows our wonder, our curiosity, but also our anxiety and our doubt. Each interstellar visitor becomes a Rorschach test. We project onto it what we most need to see. Psychologists call this projection. We take an ambiguous image, and our interpretation reveals our own inner world. That is what Oumuamua, Borisov, and Atlas have become. Cosmic Rorschach blots drifting across the night. Some see omens. Some see evidence of cosmic kinship. Some see threats hidden in the dark. But in truth, what we see says more about us than about them. The cosmic mirror reflects our stage of development. A species just beginning to step beyond its cradle, still uncertain whether to fear the forest beyond or to embrace it. We are toddlers in a universe of giants, peering out of the window, wondering whether the shadows outside are friends or predators. And like toddlers, we react with stories, myths of watchers, dreams of saviors, fears of hunters. Each visitor gives us an excuse to tell the story of ourselves again, to ask, who are we, that we should be worthy of visitors at all? The mirror also reflects our divisions. Scientists debate between caution and imagination. Governments weigh curiosity against security. The public swings between awe and fear. Atlas did not change who we are. It revealed who we already were. Some communities embrace the visitors as symbols of connection, evidence that life, or at least the building blocks of life, is scattered freely across the stars. Others respond with suspicion, arguing that to treat strangers as friends is naive. The mirror shows both impulses side by side. Even our art reveals this duality. In one painting, Oumuamua glides through a sea of starlight, a messenger of hope. In another, Atlas looms like a shrouded leviathan, its vast coma hiding unknowable intent. Both are projections, but both are true reflections of our imagination. The cosmic mirror also confronts us with scale. These objects travelled for millions, perhaps billions of years before reaching us. They remind us that our dramas, wars, inventions, civilizations, are brief sparks against their long journeys. In their silence, we see the brevity of our own noise. And yet, there is comfort in this reflection. Because if we are small, we are also part of something immense. If we are fragile, we are also participants in the same cosmic story that sends rocks across galaxies. The mirror teaches humility. It reminds us that what we fear may only be shadows of ourselves, that what we hope for may already exist within us, and that in studying the messengers, we are ultimately studying our own reflection. Perhaps that is the final irony. We scan the skies for intelligence, yet each time we find only our own thoughts, projected back onto drifting stones. Oumuamua, Borisov, Atlas. They may be cosmic debris, but in them we see our anxieties, our ambitions, our longing. And so the cosmic mirror does not answer our question. It simply reflects it back. Who are we, that we should expect the universe to reply at all? Part 11. The future of contact. If Oumuamua, Borisov and Atlas are messengers, then the obvious question is, what comes next? Will there be a fourth? A fifth? A sequence unfolding until the message becomes undeniable? Scientists have begun to plan for this, not in whispers, but in serious proposals. Rapid response probes, dedicated satellites scanning the hydrogen line, even the controversial idea of sending more powerful transmissions, declaring our presence to the galaxy. The debate is fierce. Some argue we must reach out first. That silence is itself a risk, a cosmic waiting game where no one dares to speak. Others warn against hubris. What if the first voice is also the first target? Contact does not have to mean invasion. It could mean dialogue. But dialogue across light years is not like conversation across a table. It is a correspondence of centuries. A question asked by one generation, answered by descendants thousands of years later. The future of contact is not cinematic. It is archaeological. Imagine a probe launched tomorrow, its signal crawling outward at the speed of light. If it finds a listener 100 light-years away, a reply would not return until the year 2225. No one alive today would see the answer. Contact becomes not a moment, but a legacy, a conversation carried by civilizations, not individuals. This raises profound questions. Do we have the patience to begin a dialogue we will never finish? Do we have the humility to speak for generations not yet born? And do we have the wisdom to decide whether to speak at all? The future of contact may not depend on aliens at all. It may depend on us, on whether we choose to listen more carefully, to build instruments with greater sensitivity, to remain patient in the face of silence, or whether we choose to shout louder, to carve our presence into the void, hoping someone, somewhere, will hear. Either way, the interstellar messengers have already changed the rules. We now know we are not isolated. Objects from distant stars pass through our skies. The cosmos is not empty. The question is no longer whether we will encounter the unknown. It is how we will choose to respond when we do. Speculative thinkers imagine many futures. In one, we build vast networks of telescopes, capable of detecting even the faintest artificial flicker among the stars. In another, we launch probes toward nearby systems, turning ourselves into the messengers. Perhaps one day our machines will drift across alien skies, silent and mysterious, just as Oumuamua seemed to us. We may become the unanswered riddle in someone else's night, but the future of contact is not only technological, it is ethical. Who speaks for Earth? A group of scientists with a transmitter? A coalition of nations? Or the billions of individuals who share this fragile planet? These questions have no consensus, but they force us to confront our divisions. For if we cannot agree on how to govern ourselves, how can we hope to present ourselves to the galaxy? Some philosophers warn that the first true contact will not be about aliens at all. It will be about us, how we see ourselves, how we handle our fears, how we negotiate between curiosity and caution. The visitors from beyond are a mirror. The contact is with our own reflection. Still, we cannot ignore the possibility that someday the silence will break, that a signal will repeat, that a transmission will persist, verifiable by multiple observatories, beyond any doubt. And when that day comes, the future of contact will no longer be a thought experiment. It will be history, whether it comes in a whisper across the radio spectrum, or in the silent passage of another enigmatic body. Contact will demand of us not only science, but wisdom. And so the future of contact begins now, in how we tell these stories, in how we prepare our minds as much as our instruments. Because readiness is not only about technology, it is about imagination. And imagination at last is the one thing humanity has never lacked. Part 12. Epilogue, Message Received. For more than a century, we have spoken into the dark. For a decade, the dark has answered only with stones. Oumuamua, Borisov, Atlas. 3 messengers passing in silence. And yet, silence is not emptiness. Silence is a form of reply. The universe has not ignored us. It has reflected us back to ourselves. What then is the message? Perhaps it is humility. That we are one civilization among countless others, none of which owe us an answer. Perhaps it is patience. That replies may come, but not on human timescales. Perhaps it is responsibility, that by speaking into the dark, we shape how the galaxy will first come to know us. The messengers also remind us that contact need not be dramatic. It may arrive quietly, in the form of a rock drifting past the sun. It may arrive invisibly, encoded in patterns we do not yet know how to read. It may already have arrived, and we, lacking imagination, have failed to notice. But perhaps the most profound message is this, that the act of searching is itself the answer. By listening, we discover our capacity for wonder. By waiting, we learn humility. By imagining, we remind ourselves that we are capable of hope. Message received, not from them, but from the cosmos itself. The message is that we are not alone in wondering. The stars may be silent, but our longing is real. And that longing binds us to the universe, whether or not we ever receive a reply. Maybe one day, a signal will come through the static, a narrowband transmission repeated again and again, beyond all doubt. Or perhaps a probe will reveal itself, no longer hiding beneath the mask of a comet. Perhaps the universe will one day speak to us directly. But until then, we must learn to live with silence, to treat silence not as absence, but as invitation. An invitation to listen more deeply, an invitation to look more closely, an invitation to recognize that wonder itself is a kind of dialogue. For every child who looks up at the night sky, asking if we are alone, is already participating in that dialogue. Every scientist who turns a radio dish toward the stars adds another word to the conversation. Every poet who dreams of distant civilizations writes another verse in humanity's reply to the cosmos. Message received. The messengers have spoken, not in words, but in presence. They remind us that we live in a galaxy alive with movement, with fragments drifting across eons to find us here. They remind us that we are part of a larger story, even if we do not yet know the plot. And in that story, our role is not only to wait, but to wonder. To send out our own messages, knowing they may never return. To listen, knowing that most of what we hear will be silence. To imagine, because imagination is the bridge between what we know and what we long for. So let the record show. In the early years of the 21st century, humanity noticed its first visitors from the stars. We did not panic. We did not despair. We wondered. And in that wondering, we discovered the real message. That the act of searching, the act of listening, the act of dreaming, was the contact we'd been waiting for all along. Message received. And the reply is us. Part 13. The Architecture of the Unknown. When astronomers search for signs of intelligence, they do not only listen, They also look, for not every message is spoken in sound or light. Some messages are written in structure. Technosignatures, they're called. Traces of technology so vast or enduring that they become monuments. Architecture on the scale of stars. The most famous example is the Dyson sphere. Not a solid shell, but a swarm of countless satellites orbiting a star, collecting its energy. Such a structure would not be visible directly. Instead, the star itself would flicker. Its light would dim in irregular, unnatural patterns. In 2015, astronomers noticed just such a star, Kia 8462852, Tabby's star. Its brightness dipped by as much as 20%, too extreme for planets alone. Dust clouds offered one explanation, but for a brief moment, whispers spread of alien megastructures. It was not proof, but it showed that our minds are ready to imagine architecture as message. There are other technosignatures too. Atmospheres filled with chemicals that should not be there. Chlorofluorocarbons, industrial byproducts, the fingerprints of machines. If we detect such compounds in an exoplanet spectrum, we may learn of a civilization long before we ever hear its voice. Still more exotic ideas exist. Brief laser pulses brighter than the stars themselves, planetary orbits altered by deliberate engineering, even gravitational patterns that betray hidden structures. The possibilities stretch as wide as imagination. And yet, the question remains, would we even recognize alien architecture if we saw it? We look for what we know, spheres, satellites, chemistry we understand. But what if their design principles are utterly alien? What if their monuments are carved into forces or dimensions beyond our perception? The architecture of the unknown might surround us already, and we mistake it for stars. Consider Oumuamua again, a fragment shaped like a shard, tumbling end over end, its trajectory unbound by our sun. To some, it was simply rock. To others, it was a sliver of technology, a piece of architecture that once belonged to something larger. Perhaps a sail, drifting across interstellar space until gravity bent it toward us. Perhaps debris from an ancient construction, long dead, long forgotten, yet still carrying the signature of intention. Borisov too could be read this way. Its chemistry unlike any comet in our solar system. What if those molecules were the industrial runoff of alien engineering, released into the void like exhaust fumes from a distant machine? And Atlas, its fragmented body and unusual gases, perhaps not random at all, but part of a vast lattice too large for us to see. An anchor point. A node in a network written across light years. If this is true, then the universe is not silent. It speaks in the language of structure. Stone and ice are its alphabets. Gravity and chemistry are its grammar. And we, still learning to listen, are like children misreading the letters. Architecture is durable. Messages fade. Languages die. But structures endure. If alien civilizations build with planets and stars, their architecture may outlast them by billions of years. We may not be studying neighbours, but ruins. Cosmic cathedrals crumbled to dust, still magnificent in silence. And perhaps this is our fate too. One day, our own satellites may drift as relics, our radio towers silent, our cities erased. But a fragment of us, a probe, a plaque, a record, may endure as architecture, an unknown shard tumbling through another sky, waiting to be misread as comet, probe, or omen. So when we search for technosignatures, we are not just hunting others, we are rehearsing for how others may one day hunt for us. And that may be the most profound architecture of all, the architecture of curiosity, the enduring will to search, to wonder, to leave behind something worth discovering. Part 14. The Weight of Legacy. When we speak into the cosmos, we are not only speaking for ourselves, we are speaking for every person alive today, and for billions yet to be born. Every signal we release, every artifact we launch, becomes a message that carries our name long after we're gone. In 1972, Pioneer 10 left Earth. Bolted to its frame was a small golden plaque. Simple, elegant, but heavy with meaning. It showed two human figures, a man and a woman, their hands raised in greeting. Beside them, a map of pulsars, marking the sun's position in the galaxy. It was a cosmic return address, written in hydrogen time. The following year, Pioneer 11 carried a plaque of its own. Then came the Voyagers. Launched in 1977, Voyager 1 and 2 each carried a golden record, a time capsule pressed into copper and plated in gold. On it, greetings in 55 languages, the sound of whales, the music of Beck and Chuck Berry, images of DNA, architecture, family life, the anatomy of the human body, an archive of Earth in the late 20th century, cast into the ocean of stars. Carl Sagan described it as a bottle thrown into the cosmic sea, a gesture of optimism, even if no one ever found it. But with optimism comes weight, the weight of representation. For the plaques and records were designed by small groups of scientists and artists. They chose what to include and what to leave out. The images showed human anatomy, but not human suffering. They showed music and laughter, but not war or famine. Was this dishonesty, or was it hope? The weight of legacy is this. Whatever we choose to send becomes who we are in the eyes of the universe. Not a full picture, but a snapshot, curated and preserved. And this responsibility grows heavier with time. For every new attempt at messaging extraterrestrial intelligence, MITI, raises the same questions. Who has the right to speak for Earth? A team of researchers? A single government? Or should billions of voices be heard? There is no easy answer. But the question itself reveals the weight we carry. Because legacy is not just about what we send outward. It is about how future generations will judge us for the choices we made. The legacy we send is also a mirror. It reflects not only our strengths, but our fears. To send music instead of war is a choice. To send greetings instead of silence is a choice. Every omission, every inclusion, is a declaration of what we wish to be remembered for. If tomorrow we were to send a new signal, what would it contain? Would it be equations? A universal language of mathematics? Would it be art? Colours and sounds meant to stir the imagination? Would it be a plea? An admission that we are fragile, seeking connection in the void? Philosophers remind us that the first true contact will say more about us than about them. In deciding what to transmit, we reveal who we think we are. If we send only the beautiful, we admit our longing to be admired. If we send only the factual, we admit our hunger to be understood. If we send both, we confess that we are complex, a species of contradictions. Yet the heaviest weight of legacy is not in the content, but in the permanence. Once launched, a message cannot be recalled. The golden records will drift for billions of years, long after the continents shift, long after our languages vanish. To any who find them, they will be us. This is the paradox of legacy. We cannot know how our words will be received. We cannot control how they will be interpreted. We can only choose with care, and hope that those choices endure with dignity. But perhaps the real legacy is not in the records, nor the plaques, nor the signals. Perhaps the true legacy is the act of sending itself, the courage to speak into silence, the faith that someone someday may listen. For in the end, the weight of legacy is also the weight of hope. We send these fragile artifacts because we believe our story is worth telling. Because we believe that somewhere in the long night sky, there may be another who longs to hear it. And if no one ever does, then at least we will have left a record for ourselves. A reminder that in this brief window of cosmic time, humanity once looked outward and dared to speak. Part 15. The Long Night Sky. For thousands of years, humans have looked upward at the stars, long before telescopes, long before radio, long before science gave names to galaxies. We already wondered. The night sky was a canvas of stories. Hunters and gods, queens and beasts, painted into constellations. Every culture saw itself mirrored in the stars. It was not astronomy. It was belonging. Now, with telescopes and probes, with data and spectra, we still belong to that same sky. But our questions have grown deeper. Are we alone? Or are the stars listening back? The long night sky holds its silence. Planets circle suns. Comets drift for eons. Interstellar fragments cross our path. And through it all, the stars shine. Perhaps the silence is not absence. Perhaps it is invitation. The cosmos waiting for us to grow patient enough, quiet enough, to hear its subtle voice. And in that waiting, we find peace. Because not every question needs an answer tonight. Not every mystery must be solved before sleep. Sometimes, it is enough to rest beneath the long night sky and to know that the universe is vast and that we are part of it. Close your eyes. Breathe slowly. Let the weight of the day fall away. Above you in imagination, the sky stretches forever. The same sky that sheltered the first humans. The same sky that Voyager sails into even now. The same sky that will one day carry our legacy farther than we can dream. The long night sky is patient. It has seen worlds rise and fall. It has carried comets and messages, signals and silence alike. And tonight, it carries you into rest, into stillness, into dreams. The long night sky whispers lessons, that patience is strength, that silence can be full of meaning, that wonder itself is a kind of answer. Each star above you is both ancient and alive. Its light began its journey long before your first breath, and will continue long after your last. To gaze at the night sky is to look through time, to see the past shining in the present. Close your eyes and imagine drifting outward. Past the orbit of the moon, past Mars, past the frozen giants, Uranus and Neptune, out into the Kuiper Belt, where icy bodies drift in silence, out into the Oort cloud, where comets wait in the dark for billions of years, and farther still, into the interstellar deep, where the messengers Oumuamua, Borisov, and Atlas once wandered. There, beyond the reach of sunlight, the long night sky stretches without end. And yet you're not lost, because even in the deepest dark, the stars remain. Let your breath follow their rhythm. Inhale with the rising light. Exhale with the fading glow. Each breath a tiny orbit. Each heartbeat a quiet signal, joining the chorus of life across the cosmos. The long night sky does not hurry. It waits, and in its waiting, it teaches you to rest. So tonight, let go. Let the weight of questions drift away. Let the silence cradle you. You are part of this vast story, and the story is still unfolding. Sleep now beneath the long night sky. Sleep knowing the stars have watched over countless generations, and they will watch over countless more. Sleep with the comfort that the universe is vast, mysterious, and beautiful. And as your breathing slows, and your mind drifts toward dreams, remember this final truth. The universe may not yet have answered, but your wonder, your capacity to imagine, to ask, to dream, is already the greatest reply.